some odd reason we got cut off. Understand the number of protons, tells us the identity of an atom, and the number of valence electrons. Tells us how elements react with one another. With each other. So, protons determine the identity, and valence electrons reactivity. Okay? So, if we look at our example of lithium, lithium is in group 1 with 1A. So meaning lithium has 1A, meaning 1 valence electron. So it's going to want to react with somebody from group 17, which has 7A. Remember, these 1A and 2A and all these numbers are found on your periodic table. Let's go back to that for just a second. Wherever it is. Looking at our periodic table here, you can see that here I've got 1 valence electron, here 2. Remember, skip the B's, skip the transition melody, don't follow the rule, and then so on. So my 1 lithium right here from group 1 has 1A or 1 valence electron. It wants to bond with somebody over here in group 17 because they have 7A or 7 valence electrons. All right. So remember, they want whatever it takes to get to the number 8 because 8 is great when they combine. So lithium has 1, wants 8. Valence electrons will bond with group 17 that have 7 valence electrons. All right, so I hope this is all fresh in your memory and we're not too far gone here. So when we talk about bonding, we're really talking about reacting to form new substances, right? So we're talking about how elements react. So let's talk about that for a second. So, of course, like we said, reactivity is determined by how many valence electrons. But what are some of the signs of a chemical reaction? What are those signs that we talked about? Do y'all remember? So we have change in temperature. Either the temperature goes up or it goes down when two things come together that have a chemical reaction. We have bubbling or fizzing, which just means what? That that means a gas is being made. That's another sign of a chemical reaction. We might add two things together and have a total unexpected color change. Like we had with the liquid sunshine, two clear liquids produced a bright yellow, so we didn't expect that because there was no yellow there before. So that would be a sign of a chemical reaction. An unexpected change in odor, like sour milk, or baking something, it changes odor because now the elements that you put together in that cake or whatever you're baking are changing to a new substance. What are some more examples of you might produce light, right? Like when you had that glow stick, or that magnesium started to burn, or fireworks, we have that light production. Light produced, and we didn't have any before. And then last but not least, sometimes you get that solid that forms from two liquids. That is called a precipitate. Forms, which is a solid from two liquids. So obviously you didn't have a solid before, but you get one as a result. That is a precipitate. One example, for example, of the gas, remember when we blew up the balloon with the baking soda and vinegar? That would be, for example, an example of gas production. Let's see. I think we got them all. Did we get them all? Anytime you have, and I guess we could add this to it. Let's add another one. Burning, exploding, and oxidizing. Do y'all remember oxidizing? Oxidizing was when you produce like silver and you wear your silver and it turns black. That's tarnish that is formed. That's actually something new. So it's when one element reacts with oxygen to form a new substance, and we're going to put tarnish here. So those are some of those signs of a chemical reaction or a chemical change, right? All right, so what do the elements change into? Well, they form compounds. They combine to form new substances, which are compounds. So if we start a new square, let's talk about this. So, elements. Remember, those are the pure substances on the periodic table. They combine to form compounds. Sometimes we call the compounds molecules, because molecules are any two elements in combinations, whereas a compound literally has to be two or more different elements in combination. But let's look at it. For example, hydrogen plus oxygen, and we'd need two oxygen, are going to make water, right? H2O. Oops, we need 2 hydrogens, sorry. H2O. That's an example of a compound or a molecule. You have carbon and oxygen. Here you need 2 oxygen to combine to make carbon dioxide. So here we had hydrogen plus oxygen, and that yielded or made water, right? Only 2 hydrogens to be specific. Here we have carbon and 2 oxygen give us carbon dioxide. All right, does that ring a bell? All right, sometimes you will have to be able to look at a chemical formula and determine the number of atoms or the number of elements present. So let's look at a chemical formula real quick. Let me find a good one here. Let's see. Okay, let's do this. So let's start out with 1. It's Ca, so formulas. And then we're going to say elements present. And then how many atoms. So let's start with the formula. Let's start with Ca, Cl2, O2. Well, if we look at this, we can see that we have, remember, every capital letter starts a new element. So we can see that we have Ca, Cl, and O. So the elements present are calcium, chlorine, and oxygen. And how many of each? Well, if there's no number behind the element symbol, that means there's only 1 atom present. So in the formula CaCl2O2, we have 1 atom of calcium, 2 atoms of chlorine, because remember the subscript goes with the element in front of it, and 2 atoms of oxygen. So they might ask you, how many elements are in CaCl2O2? And they tell you whatever that is. And you'll say, oh, elements. Elements are on the periodic table. They're the letters, right? So we know 1, 2, 3. 3. Make this up. Or how many atoms does this compound have? Well, it has 5 atoms. And that's total, right? Total. Okay. So what about if they asked you how many of atoms of oxygen are in CaCl2O2? Well, there are 2 atoms of oxygen, right? You know that because of the subscript 2 that follows. How are we doing so far? Is everybody okay? So be prepared to answer these questions. I'm going to do one more. Let's do one with a double subscript because we need to be able to identify those as well. So we're going to do, the next one is going to be C2, H5, parentheses open, O, H, 2, parentheses closed, 3. All right, we're going to do the same thing. So this was number 1. This is problem number 2. Let's see. So, what elements are present here? What do we have here? So, we have C, H, O, and H. Again, remember you only count each of them once. So, let me make a line here so we know we got a new problem. All right, so there is C, that means there is carbon. There is hydrogen. And O means there's oxygen. And once again, I already have hydrogen listed. I do not list it twice, I only count it once. But I have to add all the atoms of each. So atoms of carbon, C2, that means there are 2 atoms of carbon. Now I have 5 hydrogen here, but I have 2 inside the parentheses, and then outside the parentheses is that 3. So remember, when we have a double subscript like this, when something's outside the parentheses, they need to be multiplied. Multiply. So let's start with hydrogen. 2 times 3, that gives me 6, plus the 5 over here. So 6 plus 5 means I have 11 total atoms of hydrogen in this compound. Oxygen, I only have 1 inside the parentheses because there's no subscript. That means there's only 1. Times 3 gives me 3 total. So if they were to ask you how many atoms of hydrogen, you would have had to add all these together to get that correct answer. All right, I think we are good with that part. So let's talk about one more thing that we have not yet mentioned, but remember at the end of the chemistry when we had looked at all kinds of different reactions and had seen a variety of things happen, we said that in a chemical reaction, it's really important that what goes in, and I know y'all can finish my sentence, must come out. So that is referred to as the law of conservation of mass. What goes in must come out. Meaning that even though we're creating something new, we have to have the same atoms and elements on each side of a chemical equation. And remember, another way was, we said the reactants, those are the things that we mix together. The reactants, or the ones that reacted. Arrow products, you can remember this by RAP. Remember that? So let's say if you have 2 hydrogen plus oxygen, and it's going to make a product, and we call this product H2O. So what goes out? We had 2 hydrogen here, we've got them here. We had an oxygen, we have it here. So what goes in, the reactants go in, the products come out. What goes in must come out. They must be equal in elements and in atoms. So this is in, and this side was out. And this is the makes or yields arrow. But one, like we said, one way to remember this is reactants, arrow, products, or RAP. Okay? So another way to look at this is, let's say I have 20 grams of iron and 10 grams of oxygen. And I want to know how much iron oxide should come out. So my question mark is right here. How much iron oxide am I? Well, what goes in must come out. So if I had 20 grams of iron, 10 grams of oxygen, how many grams of iron oxide must I have if this is a true equation of something that happened? I have to have 30, right, grams of iron oxide for this to be a correct and honest, true statement. All right. Before we move on, I did want to add our picture. So the bubbling or the fizzing, remember we did that in the little Erlenmeyer flask. It looks like this kind of, not the best jar. And then we took the balloon and we put our balloon on top. We had put vinegar in here, so there was vinegar, and then we put baking soda in our balloon, and then put our balloon over the top, poured the baking soda in, and it blew up our balloon. So that would be an example of gas produced. Remember, it blew it up because it started fizzing and bubbling, and it blew up our balloon. Do y'all remember that? I hope so. All right, so that would be an example of a gas production. All right, this is the chemistry portion, and we're going to break now because this is the chemistry part that you needed to know. So I'm going to stop the video now, and then we'll start with the next topic.